Hi there, everybody. We're going to start today with Chapter 9, APES Chapter 9 lecture. Now, this chapter is all about agriculture and soil and basically how we grow our food for the most part. All right. So let's begin. Let's define a few terms. Agriculture. Well, this is what we do. We raise crops. We grow food. We have livestock. We feed basically. We get fed from all these things. Why is this so important? Well, food is a very important limiting factor for everything that's alive for the most part. We need food. So agriculture has made our lives a little bit better. We're no longer traveling around looking for food constantly. It enabled us to have cities and areas where people can reside in, and we can grow food next to those areas, and therefore we didn't have to transport things very far. Rangeland is land used for grazing livestock, cropland for growing the foods that we like. Look at this. 1 out of every 3 acres of land is used to produce food and fiber and to grow something, basically. 10,000 years ago is when they believed that agriculture became prevalent. People went from a hunter gatherer lifestyle and they started growing different types of grains, different kinds of foods, different kinds of fibers, whatever happened to be that they needed. It was believed that they evolved, the ability to do this evolved independently. The different people in the different parts of the world shows you here that they have independent origins, basically, meaning that they started using agriculture for themselves and they weren't being influenced by another part of the world. All right, so it shows you where and how things evolved, and how they evolved independently of each other in different parts of the world. All right. Traditional agriculture, back in the day, people, and still to this day, people would use a lot of human and animal muscle. They grew, for the most part, what they needed. All right, that was subsistence farming. All right. Intensive agriculture, well, the same farmer said, well, maybe we can make some food. What if we grow some extra potatoes or some extra corn? Now we can start selling it. So intensive agriculture started to take place. People started selling their food, basically. All right. How did they do this? Well, they started using more fertilizer. They needed irrigation. They needed animals to help with the work. Well, today, because we have so many people on our planet, and we had this thing called the Industrial Revolution, it's industrialized. And the Industrial Revolution, in this case, for agriculture, the Agricultural Revolution happened and it industrialized the process. Machines, fossil fuels are being used to run all these machines. Irrigation is all done manually. It's not manually, excuse me. It's done by machinery, timers, synthetic fertilizers, chemicals are being used like crazy. Basically, they've turned it into a factory, into a machine. All right. Monocultures. Well, here's a picture of a monoculture. When you drive through farm country in California, you see a lot of monocultures. What are they doing? A single crop. Why do they do it? It boosts their yields. They are only worried about one thing. It makes their life simpler. It's more efficient because they're only doing one type of crop. It's generally more profitable for farmers. So this is the main type of farming you'll see industrialized monocultures. Why is it bad? Well, it's not very natural to only grow one type of plant on this, and most of these plants are seasonal plants. So most of the year, the land will probably be even barren. There'll be nothing there. That's a problem with a monoculture. What does that do? Well, it basically causes erosion to take place, makes soils more prone to erosion because there isn't always something covering the ground. Because you're growing only one kind of thing, the nutrients in the soil they're not the way the nutrients would naturally be in the soil. So what do you have to do? Lots of chemicals are used to make up nutrients to kill pests that may show up. Now you're talking about polluted groundwater. So monocultures is the way most of this industrialized farming is taking place. It makes more food, it makes it more efficient, it's more profitable, but it does have a lot of negative impacts on the environment. Polyculture, showing you down here, growing mixed crops in the same field. It's more natural, I would say, because you have more habitat. This is strictly one type of habitat where you have different habitats, different species, more biodiversity, better for the land. There's usually things always covering the land and growing. You don't have barren soil throughout the year. It's better for the earth to grow a polyculture. But this is not the way intensive farming and agriculture and industrializes. It's not the direction it's gone in. This is the direction it's gone in monocultures. In the 1950s, the Green Revolution took place. All right, this is like the agricultural revolution, so to speak. Well, what did they do? They got really, really good at growing food at a very large, grand scale. What did it do? It started feeding people throughout the world. There used to be a heck of a lot more people that were starving around the world. And now a lot less people are starving as a result of our ability to grow more food for people. If you go to a lot of these third world developing nations, you'll notice a lot of the people don't eat meat. They don't eat meat because meat would be extremely expensive. Because of how much energy is lost up the food chain, they can't spend all that food. They can't afford to give all those plants that they grew to a cow to eat just to make steak, where they can actually feed a large number of people. All right. Think of it this way: 100 kilograms of vegetables, all right, would produce 10 pounds of steak. All right. 10 pounds of steak, let's say, can feed 10 people. 100 pounds of vegetables could feed 100 people. It's much better for the earth if we were all vegetarians. Soil. Soil is a bunch of things mixed together. It's not, most of you think of soil as just the rock matter, the small particles of rock, and that's not what it is. It's a bunch of living and non-living things living together. It requires biological activity. It requires organic matter, living matter that's decomposing. It requires insects, mice, fungus, bacteria. There's minerals, rock matter right there. Space. It needs space because roots need to penetrate and water needs to flow through it. Soil that's very compact is not good because roots can't penetrate it, water can't penetrate it. It's not good for growing crops or growing agriculture. Right? Soil. Now, soil is a hot commodity. It is important because this is the way we grow our food, the way we farm. We are not doing things sustainably. We are losing too much soil due to erosion. So without soil, you really don't have an agricultural. You don't have agriculture at all for the most part, right? You need healthy soil and you need intact soil. Wind and water move it very easily. All right. Plants, they need nutrients. All right. We talked about nutrient cycles in a previous chapter. Where they take in their nutrients, they generally take in their nutrients through their roots. All right. They take in their nutrients through their roots. So this is showing you phosphorus and nitrogen. Certain fungi called mycorrhizae, we had them in a previous chapter. Well, what do? They have a mutualistic relationship with plant roots. What does that mean? Well, what do? They can increase the surface area of the roots. And as they increase the surface area, now the roots can penetrate more areas, and therefore they can absorb more. What does the mycorrhizae, what does that fungus get out of this relationship? Well, they get food from the plant. So they get food, and the plant benefits by being able to pick up these nutrients more efficiently. All right. Okay, so whenever we talk about parent material, we're talking about bedrock, the rock that begins the base of that starts the formation of soil, right? So you start with bedrock, and this is showing you a horizontal profile. Down here, the bedrock, basically, and then it starts getting weathered as you go up, and then you get to subsoil, and then you get to topsoil, and then at the very top where it's very dark, you get the humus, all right? What's a parent material? What can it be? Well, it starts out as lava or a glacier retreats, and flowing water of an area starts basically forming, well, removing everything in the process and exposing only rock. All right. When dunes get windblown, there's no small particles left, and you're just left with rocks. So that rock material that starts the formation of soil is bedrock. All right. How do you break down that soil? Well, excuse me, how do you break down that bedrock to make soil? That is not erosion. Erosion is moving it away. Weathering is what breaks it down. It could be physical. Here's a picture of physical weathering. Water gets stuck into a crack. It freezes. It forms a wedge. Keeps happening. Eventually, it breaks it. A big boulder or big rock, a bigger piece of rock material into smaller. And then it happens again. And then it happens again. And it happens again. Wind, rain, freezing, thawing. This is physical weathering. Chemical would be, for example, like acidic compounds that are produced, and those will chemically alter the rock. Water can dissolve things and cause chemical reactions to take place. Certain gases, along with water, can cause reactions to take place. Biological weathering, when you're involving lichens, for example. Lichens, I said, lichens produce the acids. Those acids help break down the rocks. That's how rock forms when we're talking about succession. All right. Tree roots, man, they can crack your sidewalk. They also can physically They technically physically break it down, but it's happening by a biological source, so it's considered a biological weathering. So weathering, physical, chemical, biological, these things together combined can break down big pieces of rock and make smaller pieces of rock. All right. Then biological activity also decomposes living things. And as they break down, their waste products or their actual organisms, as they break down, they become part of the soil. So soil is not just the physical, the actual stones being broken into smaller pieces. You need all the living matter decomposing, decaying, breaking down. All right. Humus, real dark, spongy, crumbly mass. This is when you see soil, it's really dark, it's full of humus. And that means there's a lot of organic matter present. That's healthier soil. All right. So you need to know how weathering is affected by a lot of factors. Why? Because soil formation is important. All right. So I've seen AP test questions specific, and I won't lie to you guys, they're very difficult. The test questions about soil are generally very difficult. Things you need to know about soil. Well, you start with bedrock, okay, apparent material. Time. Soil does not form very quickly. It forms very slowly. So it requires a long time for soil to form. Soil is renewable as long as we don't overuse it and grow too much food, therefore, and cause too much erosion. It is a renewable resource. It's important. What else is involved in soil formation? Well, the land, the hills, the terrain, how much sun is present, wind, water, you name it, the topography of the region. The organisms present in the soil help produce the soil. So having the right plants, decomposers, fungi, bacteria, and the actual, they start breaking down the organic matter. You need the right things present for it to be healthy. Important factor you really need to know. And this was on an AP test question, talking about climate change and how it could impact soil formation. Well, as it gets warmer, all right, moist climates accelerate weathering, all right, and increase the rate at which soil forms. So soil, when it's warmer, can actually be produced faster. All right. But be wary of that. All right. Be wary of that. Sometimes when it gets warmer, you get too much rain. If you get too much rain, you will cause erosion to take place and you'll lose a lot of the matter and the material you need that is needed to produce the soil. So climate has a major effect on it. It gets warmer, well, weathering increases the rate of weathering. It increases the rate at which decomposition takes place, and it increases the rate at which soil can form. But it can also do the reverse. It can cause too much moisture, too much rainfall, which can wash away the needed nutrients. So climate can affect things differently. Beware of how it's asked on an AP test. Horizons, these are the layers of soil. Okay, so soil layers. All right, soil layers. You start the very top layer is organic layer, litter, things that end up on the ground. Then you have the topsoil, which is a little darker in nature. People apply topsoil when they're growing things at their house. Then you have a leaching layer. Okay, leaching, bad thing. If something is being leached, it means it's getting removed. Okay, it is getting removed. So leaching is not good. Soil leaching means minerals are dissolved and removed. In most cases, they're transported downward. But in general, if leaching takes place, it's not good. Minerals, nutrients are removed from where you want them to be. All right, they're generally being dissolved and washed away for the most part. All right. Okay. All right, let's talk about the horizons. The O horizon, this is the litter layer. This is your organic layer. So deposition, organisms are dying and they're falling. Plants and animals, you name it, they're dying. Their matter is being deposited. The O layer, the O horizon. Okay. The A horizon is next. This is called the topsoil layer. So this is a mixture. It's a mixture of humus. I already said that, organic stuff. All right, mixed with inorganic stuff. So rock material. So organic and inorganic mixed together. That's your topsoil. This is generally what you would lay down if you're setting up a garden at your house. Topsoil. You may add organic matter to it in the form of compost. You might have compost. We'll talk about that in a little while. All right. Topsoil is the most nutritious part for the plant. Basically, this is what we would lay down if we're growing food and crops. All right. The E horizon comes next. All right. Eluviated means this is the leaching layer. This is where a lot of leaching takes place. A lot of minerals are leached. They're dissolved by the water, and then they drip through, and then they're lost from the soil. These minerals are important for soil because they make the soil nutritious. All right. The B horizon, all right, this contains the stuff that came from the E horizon. So the stuff that leached from above ends up down here. Why is that a bad thing? Well, it's too low. The roots aren't penetrating that low. So therefore, this area will have minerals and organic matter will build up here. All right. They'll build up here, but it's not the best place for them to be. All right. The C horizon. Well, this is partially weathered. So this is like rock material that's still a little larger. And then at the very bottom, R, this is the bedrock or the rock. So our rocky material in the R horizon. Our C horizon is these pieces broken down, smaller pieces. Our subsoil is minerals and organic matter that are building up there. E layer, our leaching layer, where it's removing a lot of the minerals that are important. Our topsoil is our nutritious layer. And finally, our organic layer at the very top, things that are decomposing. Soil differs in its quality. This is showing you topsoil being laid down before these people lay down their sod. They want to lay down the most nutritious type of soil so that this grass will grow and root, basically. And this is showing you a picture of the layers. The O horizon at the very top, the A, the E, the B. Notice how it gets lighter and lighter and lighter. It means there's less organic matter present. Darker colors are usually rich in organic matter. Pale colors like beach sand, not full of organic matter. Beach sand, not very nutritious at all. I dare you to try to grow something in beach sand. It's not going to grow very well. Soil texture. Basically, what is soil made out of? All right. 3 particles. Clay, the smallest. Silt, the medium size. And sand, the large size. All right. Smaller size, more sticky. Larger size, not as sticky. All right. So stickiest, least sticky. All right. Smallest, largest. Loam is a mixture of the 3. So this is a pyramid or a triangle that we're going to use on how we classify the soil that we have in a particular area. And it'll fall into one of these categories, and I'll show you in a second how to use it. All right. Clay. Well, clay soils, not very good. If you've ever played with clay as a kid, it's very sticky. Clay can seal things, basically. Water does not pass through it. All right. Air cannot pass through it if you seal it correctly. Roots don't pass through it. So if you have soil with a lot of clay in it, or soil that's very compact, well, it behaves like clay. It's not very good. Roots don't penetrate it. Water doesn't flow through it very well. Air doesn't flow through it. Okay. Sandy soils like beach sand, not very good. Water moves through it too quickly. You got to keep irrigating. So dry, sandy soils, you got to irrigate them a lot because it moves through them so easily. Loamy would be medium-sized pores, and it's considered the best. Loam is a mixture of all 3 particles. All right. Loamy soils are generally the best because it's the medium size. The pores are the right size. Air and water can move through. Roots can penetrate. All right. So least sticky to most sticky, sand to clay. Clay is very sticky. Things can't even pass through it. All right. So here's how the chart works. If something falls right here where my pointer is, we would start with the first one, clay. All right. See how the numbers are going this way? Well, these horizontal lines are their lines. All right. So if I set a point here, that is 50% clay. All right. Now, this here 20 would be silt. So it would be 50% clay, 20% silt, and that would make it 30% sand. How do you know which line to use? Well, you'll notice the sand lines the numbers are tilted sideways this way. You'll notice that the silt lines, the numbers are tilted towards their lines this way. And you notice that the clay, the lines are going this way with their numbers. So the numbers give you an idea of which lines to use for that side. Be wary of that, all right? So if we're down here, over here, well, this is 20% clay, 70% silt, and 10% sand. And then it would be a silty loam. Ideally, loam is the best. Very sticky, too many pores. The pores are too big with sand. All right? Clumpiness. Well, if you till soil, which means it gets turned over, and we're going to talk about that later, it starts getting compacted over time. Compacted soil is not good. Roots do not penetrate it very well. All right, so clumpy soil, not very good. Roots cannot pass through. Water will get stuck in areas too. pH is another factor. Ideally, it wants between 6 and 7, almost like 6, really 6.5 to 7.5 is ideal. All right. Too acidic or too alkaline, it affects how they absorb nutrients and how the soil can hold on to those nutrients. All right. When soil gets very acidic, certain things get dissolved and those nutrients leach away for the most part. So acid rain, it leaches away things. Minerals that are important for the plants to grow, they get removed. A lot of these are metals, aluminum, calcium, potassium, magnesium. They're on the left side of the periodic table, left side of the stairs on the periodic table. Okay. When you remove a lot of these, you get a lot of sulfur and nitrogen in the soil. That sounds great, but you're also missing a lot of these micronutrients that would be needed. And some of them are macronutrients. What do we do to treat acidic soil? Well, you can add a base to it, but be careful because if it gets too basic, it creates more problems. The most common base, I would say, would be like limestone or gypsum. These are alkaline or basic, and you can add them to acidic soil as a remedy to if it gets too acidic. And regional differences, well, rainforests, they have really bad soil. It rains so much that it leaches so many nutrients away, and that rain dissolves a lot of metals like aluminum, and it becomes very acidic. Well, then how do these giant trees get all their nutrition? Well, there's so much decay going on here, and all that rain will start flushing some of these decaying microorganisms and what they're breaking down and decomposing. It'll flush through, and then they'll pick it up in their roots as it goes through. It's not the ideal situation. It's better if it's in the soil, but it's not available to them in their soil because of how their soil is made up, basically. All right. Most of the nutrients in rainforest, they're above ground. I just said that. They're the decaying matter. They're not below ground. There's way too much leaching because of how much rain is taking place. And it's acidic, so it can't hold on to a lot of those nutrients. All right. Swidden agriculture is where they cultivate a plot of land and then they move over to another plot of land. And the hope is that it can recover. It's not always the case. These are third world countries. They're destroying land. How do they clear the land? They slash it and burn usually. That's usually what they do. Yeah. And we'll stop there.